Okay, so let's get to question number 8. So, folks, we're still on exam 1 from 2015 fall semester, and we're doing question number 8 over here. It says, what is the maximum number of electrons that can be accommodated in the orbit when the quantum number is numbers n equals 6 and l equals 3? If you remember from your classes, that the quantum numbers are the... Oh, where's my... Oh, here. Well, I think it's a little bit off, isn't it? It's well, whatever. Um, so n has to be something that's greater than a zero, and L is belongs to from 0 to n, but it doesn't include n. Like uh it's greater than 0, greater and equals to 0, and it's smaller than n. It cannot reach n. And there's another two says ml and ms, and ml equals to from negative L to L, and ms is only belongs to, there's only two possibilities. It's either negative half or positive half, which means the electron is either spinning upward by our definition or downward by our definition. And ms is the the sub level for each, it shows like how many electrons can it be held in this particular sub level, and that number L shows the sub level of sub level, and it shows the, I guess that's not how we write level. Lever. Okay, so this shows the sub level, and this shows the main level, like this number over here. It shows like which grand orbital it's in, and this shows like which sub level the electron is, which sub level the electron lives. It's kind of like the global mailing system, I suppose. Like, so this is like which city do you live in, and this is like the street name, and this is like the, I don't know, the, is that the post number? Is that what people say is it? I don't really know. So it's kind of like the, this is the name of the city, and this is like the road's name, and this is like your like the door number, whatever. I think that's the more accurate term. And this is like for whom, like the name of the person. So it kind of describes like which electron are we talking about in one molecule, or in one, I'm sorry, in one atom. And so and they have to behave in such a rule that they cannot get out from this range, otherwise it won't be an accurate description and people won't know what you're talking about. And so for this particular question, it says n equals 6, n equals 6, and l equals 3. So this gives us when n equals 6, l can be from 0, 1, 2, 3, 4, and 5. And so let's see how many numbers of electrons as we talked about. So it's the door number, how long the street is. So it's from negative L to positive L, as we showed over here. So it's from negative 5 all the way to 0 to positive 5, which gives us a total of no, I'm so sorry. It's the L is 3. It's described over here. So we can only from positive 3 to negative 3. That's what I thought. It's such a big. So it's from negative 3 to 0 to positive 3, which gives us a total number of 7 sublevels of electrons. 7 sublevels. And remember, for each levels, there's for each house on the street, there can be 2 people living, which is the one called plus a half and the other one called minus a half. So there's a total number of 14. So it's 7 times 2, which gives us 14 electrons. And that's, I believe, answer E over here. So E is the correct answer for this particular question. And I hope, well, this I hope like this system over here makes sense to you, so it'll help you a little bit. Actually, I have figured that my pen doesn't really like when I'm circling this, it doesn't really move. I have to move my mouse around to show you. I do hope that this software has some kind of like a I can probably just circle it like, oh no, like circle it like this, but I do hope there's like a laser pointer or something like that. Never mind. So we're in the problem over here.